Hi everyone. Wanted to make this video so I can give you guys some more examples to add on to the video you guys watched yesterday. But first, I just want to say we really do miss you all. It's weird, being home and not seeing you guys get to learning. It sucks we're not going to be able to go back this year to say goodbye. So I hope you all stop by next year. Hope you enjoy hearing my voice in this video and know that, we're trying to do the best we can to make sure you guys get the education you deserve. So this video will just continue to talk about a different kind of linear equation, which yesterday you learned about point slope form. So that's this y minus your y coordinate equals your slope times x minus your x coordinate. Previously we had learned about slope intercept form, which is y equals mx plus b, where you have your slope is m and your y-intercept is b. Both forms are super useful. So what we're going to kind of talk about as we go through this video is when would you want to use one form or the other. This may be a review for some of you, but it's actually going to lead us into something we do towards the end of the school year. So I just wanted to make sure we were all okay with this idea. So I have a couple different scenarios here. Highly recommend you take notes so you can reference them later. But this video will be here forever in case you want to look back at it. Okay, so the first one says write a linear equation with m is 3/4 and b is -2. Okay, so m is your slope. B is your y-intercept, as a reminder for those variables. So if you have a slope and an intercept, you should use slope-intercept form, which is y equals mx plus b. Okay, now all you need to do is substitute the values for m and b in to get your equation. So we'd have the line y equals 3/4 x plus b, which is plus -2. Or you can write it as y equals 3/4 x plus -2 means the same thing as -2. Either way, you're both taking away 2. So again, that slope-intercept form, that should be very familiar. Have the linear equation. You can plot the y-intercept at -2, rise 3, run 4 in the positive direction to graph your line. Okay, then we learned about point slope form, which is really useful if you don't have the b value, if you don't have the y-intercept, such as b, when you only have 4, -5 is one of the points. And m is your slope is -7. So in this case, we're going to want to use point slope form, which I always start by just writing it down. Y minus your y coordinate equals x minus your x coordinate. Okay, and then I'm going to plug in my slope and I'm going to plug in my point. So my slope here is -7. That's my m. This is the x coordinate. This is the y coordinate of your point. We'll call this x1 and y1. It just means your first x point and your first y point. So it's y minus your y coordinate. So it's y minus -5, double negative there because you have subtraction sign in the formula and in the coordinate. And then you have x minus your x coordinate, which is x minus 4. Okay, simplifying that, minus -5, when you subtract a negative, it's adding. So that'd be y plus 5 equals -7 times x minus 4. Okay, and that's how you would write that equation in point slope form. So you could look at this equation and say, okay, I'm going to plot this point for -5, then I'm going to rise 7, run 1 to get my slope is rise over run, and you could graph your line from there. Okay, you don't need a y-intercept to write that, you need a point, and there are a lot more points on the line than there are y-intercepts. So actually, point slope form is more commonly used in higher level math. So when I teach Algebra 1, when I teach geometry, 9 times out of 10 I'm using point slope form. Okay. Now you have a slope of 9/2 and it's going to the point 0, -1. Okay, so you can actually do this one in 2 different ways. If you recognize that 0, -1 on a graph, 0 is your x coordinate, -1 is your y coordinate, that would be right here. That actually is your y-intercept. Okay, just written in a different way. So you could write it in y equals mx plus b form, okay, by plugging in 9/2 for your slope and -1 for your y-intercept. That is one option. If you didn't recognize that, you can also write it in point slope form and you'll get the exact same thing. Okay, so it really technically doesn't matter which one you choose, but you want to pick whichever one's easiest for you. So if I do that, y minus my y coordinate would be y minus -1 equals my slope is 9/2 times x minus my x coordinate, which is 0. Now if I simplify that, that would be y plus 1, because you're subtracting a negative, equals 9/2. Well, that would just be x minus 0 is x. Okay, and if you move the 1 over, you get y equals 9/2 x minus 1. You see, it's the exact same thing as when I wrote it in y equals mx plus b form. So you can either write it like this, or you can write it like this. Either one is fine. You have options for whichever one's easier based on the scenario you're given. Okay, in part D, it's a little trickier because you will notice in order to use slope-intercept or point-slope, you need to have a slope. And were we given the slope? No, we were not. So we're going to have to calculate it. Okay, remember your slope is, m is your slope, first of all, and slope is rise over run. Okay, now rise on a coordinate plane is up and down. We're talking about our y coordinates. So to find the rise, you're going to subtract the y coordinates. That'll give you the distance between them. Run is horizontally, it's this way. Run is your x coordinates then, so you're going to subtract your x coordinates to find the run. Make sure rise is on top, run is on bottom to get that ratio of steepness. Okay, so again, this is x comma y, x comma y. You've got to call one of them 0.1, the other one 0.2. Doesn't matter which you pick. So maybe I'll call this x1 and y1 and this x2 and y2. I don't know, it doesn't really matter. So I take y2, which is 10, and subtract y1, which is 8. By the way, I picked this one to be the second coordinate because 10 minus 8 is easier than 8 minus 10. Just a personal preference. Then I take x2, which is 3, minus x1, which is minus negative 2. Okay, so subtraction in the formula, and then there's also a negative. 10 minus 8 is 2. 3 minus negative 2 is actually adding 3 plus 2, which is 5. So your slope for this equation is 2/5. Now I can write this in point-slope form or slope-intercept form. Well, we don't actually have the y-intercept, so I probably wouldn't use slope-intercept. I would just use point-slope because I have 2 points. So you can do either point. You can do y minus your y-coordinate equals your slope times x minus your x-coordinate. You just have to plug a point that's on the line, and both of these points are on the line. So I could do y minus 10 equals my slope times x minus 3. That is a perfectly good answer. Okay, you can also write the equation as y minus 8 equals your slope times x minus your x-coordinate, which is x minus negative 2. Okay, either equation will work, and if you put them in point slope, would actually wind up being the exact same thing, be equivalent. Since both points are on the line, both of these equations will help you graph the line. You can choose. Okay, so that's just a quick reminder of how you write equations in both slope-intercept and point-slope form. Again, now you have options. You have 2 different equations, and the reason you have 2 is because sometimes you have a y-intercept and sometimes you just have a point, so you have different equations to fit the information you're given. So again, I cannot stress this enough. I actually use point-slope form a lot more as I teach higher-level math, such as Algebra 2 or geometry. So I really wanted to go over this again and re-emphasize what you do with that. Okay, last but not least, I'm going to start getting into the reason why I'm doing this. And in order to do that, I'm going to use Desmos real quick here. So what you guys see here on the screen is I just have an equation of a line, y equals negative 7x, technically plus 0. So the y-intercept is at the origin, 0, 0. So that means the slope, since it's attached to the x, is negative 7. So I'm actually going to talk about this problem right here that also had a slope of negative 7. Okay, the only difference between part B and what you see in Desmos is that part B also goes through the point 4, negative 5. So 4, negative 5 would be, if you look 4 on the x, negative 5 on the y would be right here. And as you will see, this line does not go through that point because I didn't tell it to, right? I didn't do point slope form. So I'm actually going to transform this equation to show you what's going to happen as I change the line. So first and foremost, you would do y minus your y coordinate. So it would be y minus negative 5, which then you see, even though it's negative 5, it's actually plus 5 in the equation to get a y coordinate of negative 5. So it's kind of the opposite of what you think. It looks like plus 5, but the y coordinate is negative 5. So I'm going to plug that in here and show you what happens. Okay, so this was my original line. Okay, and now I add 5 to the y's. And since we're talking about the y's, I want you to specifically look at what's happening to all the y values. So look at this point right here at 0, 0. Now I'm adding 5. That y-intercept has gone down to negative 5. So what's actually happening when you do y plus 5 is you're transforming the function with what we call translation. A translation moves something up, down, left, or right. And this translation, again, focus on that y-intercept, goes from 0, 0, plus 5 brought it down 5. Okay, so that was a translation on the y-coordinate to bring it down. A y translation because you added it to the y-coordinate. Okay, I want to do the same thing with the x. So right now it's really, not in point slope form. This is technically x plus 0. But the x-coordinate we wanted in this problem was 4. So as you see, you plug that in, it'd be x minus 4. Again, even though it's positive x-coordinate, it's negative here because there's a negative in the equation. So it's the opposite of what you think. So I'm going to plug in x minus 4, and I want you to look at what happens on the x coordinates. Okay, so focus on this point again, 0, 0. Now it's going to move. Okay, it started here. It went over here. Oops, I meant to make that a 4, not a 5. There we go. Okay, so it was at 0, 0. Now that point is at 4, 0. So it's moved over to the right 4 units. Okay, so we call that, again, a translation. A translation moves something up, down, left, or right, but this translation moves it to the right 4. Okay, so I'm going to put both values in right now. So that was y plus 5. And now you're going to see that that point 4, negative 5 is here. Okay, so this equation, with the addition of the plus 5 and the minus 4, has done two things from the original. Again, this was the original. Okay, it has moved to the right 4 units, and it has also moved down 5 units. And that is how you get this point to appear. Oops, where'd it go? There we are. 4, negative 5, you see the point. Okay, this is actually true of any equation. So I just gave you a line, and I had it transform in different ways. But hopefully this also looks familiar. We have a parabola, y equals x squared. Okay, so this shape is called parabola, if you haven't heard that before. I can do the same thing and transform it to make it move up, down, left, or right. Okay, so let's say I take my x value, which is just x right now, and I'm going to do the exact same thing that we did to the line. So I did x minus 4, which moved it to the right 4. I'm going to do x minus 4. Boom. It moves it to the right 4 as well. Okay, you can transform any equation the same way. Just to prove it, I'm going to show you guys an absolute value equation. Okay, absolute value, remember, is with those bars, makes everything positive. I'm going to subtract 4 from the x. Boom, moves it to the right 4 as well. Okay, these are called transformations. So transformations are things like translations, which moves it up or down, left or right. Reflections, right, where we can reflect over the x-axis. I can reflect this over the x-axis too. You can also do a rotation. Hopefully you guys have heard of these things in previous math classes. But I just wanted to point out that every single shape, whether it's a line, so again we had that negative 7 times x minus 4, and that moved to the right 4, or whether it's a parabola, we had x minus 4 squared, and it also moved to the right 4. Okay, that transformation works exactly the same in lines that it does in parabolas. Just to prove it, do one more shape. Let's say we have, I don't know, a square root. So this guy's a square root. Okay, it starts by looking like this. It's the square root of x. Looks like a little shooting star. And now I'm going to subtract 4 from the x. And look, it also moved to the right 4. Okay, so this is just a little preview of why I'm telling you about point slope form. It's because point slope form helps you see that transformation. It helps you see it move left or right or up or down. And this is going to be very important for what we do later in our e-learning. So I just wanted to bring that up now. Anywho, now that we've kind of just observed those trends, don't worry about it too much for now. I'll bring it back up again later. But really the point of this video was to review point slope form, review slope intercept form, and if you have any questions, please write them into the video and I'll make sure they get answered. Have a good rest of your night.